Hi guys, welcome to Introduction to Programming, written by myself, Adedoyola Nipekun. In this particular tutorial, we'll be discussing how and what programming language is all about. Sincerely speaking, programming is a very broad technology or terminology. So we'll actually be streamlining it to just the basic, touching the basic here and there. So we'll have in this particular presentation now and tutorial, we'll be having to discuss the contents. What are the contents we have for this particular introduction to programming? We have what is programming, types of programming languages, how to know a good language, and finally, what are the frequently asked questions that comes to mind as a new or incoming developer or programmer. So let's start with the first one, which is the part one, and what is programming? We can say a programming language is an artificial language that a computer understands. Simply put, for a computer to understand whatever you're saying, you speak in its language, and that's an artificial language that the computer understands. The language is made up of series of statements that fit together to form instructions. These instructions tell the computer what exactly needs to be done. In simple terminology, you give an instruction to a computer and tell the computer what you want the computer to do. That is simply put programming. And we have the definition, we have the importance of programming, we have the classes and functions. After we have actually touched the definition, what's the next thing to talk about? Importance of programming. What do you think is the importance of programming? It helps to solve problems, it helps to throw more light into things, let us know what and what needs to be done, how it needs to be done. And there are different and many types of programming languages. Some are more complicated than the other, some are more complex than the other. But amongst them, I'll just mention a few ones which are kind of relatively popular in their own industries. We have the Python, we have the Java, we have the C++, we have the Basic, we have the Scratch, you have the Flutter, you have a lot, and each of them has the strength where they're actually majorly used, from the webs applications to the mobile applications to desktop applications to even embedded systems. So you have different programming languages for different scenarios. So we have classes and functions. What do we mean by classes and functions? These are the logics that you put in place, the structures. See a class like a room that you can put different things in. So let's say a class has a body where you can actually put functions and command into. So a class holds the body of the instruction you want to give the computer. So for that reason, we have different classes. You can define your classes. You have some standards you have to follow, because every programming language has its own standard and its own policies to be followed. So if you don't adhere strictly to the standard of those programming languages, you might have some challenges communicating or interacting with in that language. So it's always good to know that the group of instructions you're giving actually meets the standard in which you want it to be given. Then we have tags in programming. Tags are like commands. They're not even like they are commands. The commands you give. So for instance, if I want to write a simple A plus B equals to C, that is a command. I want you to do an arithmetic sum or arithmetic operation, which is a sum. And I want it to add an object A and an object B and give me an output C. So that's a command. So I have to put this in a logic, which is either a functions or procedures, so that it can actually perform that operation and give me desired output. That's basically the summary of what programming is all about when it comes to definitions. So we're going to move to the next part, which is the part two. And in the part two, we're talking about different types of programming languages. As I mentioned earlier, we have different types of programming languages, but these are actually classified into three basic parts. So the first part, we have the traditional. Second part, we have the OOP, and the third part, we have the special. What do you mean by traditional? So when we talk about traditionals, we mean the first, second, and third generations programming languages. Things that will come to mind will be the Fortran, the COBOL, the Basic, and all that. Those are the very, very traditional programming languages. They're actually taught straight to the hardware system. They are low level. You can also refer to them as low level programming languages. Now, after a couple of years, researchers actually eventually come up with the fact that you need a much more friendlier approach to writing programs. So we came up with OOP. So researchers came up with OOP, and in that OOPs, we have the full meaning of OOP is object-oriented programming. These are actually the fourth generation programming languages and above. That's where we have applications or programming languages such as Java, Pythons, the Flutters. Do you understand? The JavaScripts, the Pythons. I think I mentioned Python, the C sharp, and all that. At that point, we're actually having object oriented, where we can have different objects come together to form your source or your products. So you have different objects. You can reuse them. Those are the advantages. You can reuse them. You can do a lot of things with it. And the special, these are the scripting and command languages. When you talk about scripting languages, that's where JavaScript comes to mind. There are different kind of special programming languages, which when we get to the next class, we'll talk more about it. Now we go to the next topic, which is how to know a good language. Don't forget, there is no hard and fast rule to know a very good language. So I'll say it again here and now. Every language is good. The scenario in which you need to use it differs. So based on your requirement, that determines the kind of programming language you should use. Also, we need to be conversant with the industry to know what is really applicable. So that also guides the language or programming language you will use. So for you to know a good programming language, there's some four basic things you need to actually look into. One, as I said, ease of designing and coding. If you're starting out into programming, you need to know what are the design methodologies in place, the coding techniques and styles, and how to easily get resources. If you're going to be learning, self-learning, if you're going to be going to schools to learn using videos and all that, you have to know each or different types of programming languages, their coding techniques, their ease of design, availability of support, availability of resources, and all that. You have to look into those things before jumping into a particular language. Also, ease of debugging is always easier in one application than the other. Every particular programming language has its own strengths and its weaknesses. So you have to make research on the strengths, the ease of debugging, availability of resources, compatibility with other compatibility with other kind of programming languages, supports, and all that. So that will help you when you're debugging to make it easier. Then maintenance. As we've said, a lot of programming languages are faded out because they have not been maintained over the period of time. So with time, they tend to ease out. They tend to fade out because there's no newer versions, there's no newer compatibility. So you have to be careful not to just dive into those kind of programming languages. So you don't use things that are obsolete. Obsolete though, but there's still maybe some particular industry are still using those technologies. So the last part you have to look into as well as a new tech guy is reusability. What do I mean by reusability? Any language that you're going to be learning should be a language that you can easily reuse. Do you understand? So if I'm going to be designing something now, or an application, web app, mobile app, or something, can I reuse my code? Or every time I need to do the same process, I have to start all over again? Are there libraries, are there packages available to make my development easier and faster? Because for instance, if I develop an application today and I use a particular technology, and tomorrow I need to use that same technology, do I have to start developing or designing from scratch? Do you have my classes that I can actually just import into my new environment and use? These are things you have to look into carefully before actually concluding on this language is good or the other is better. So finally, we'll be moving to the frequently asked questions. As a new tech person in the industry, or you're trying to come into the tech environment, there's some questions that actually will be lingering in your mind. You'll be wondering some questions here and there. I have just a couple of questions, but you can also drop more questions for me in my comment section. I'll always be in the comment section to answer those questions. So if you have questions, just drop it there. But these are the basic questions that came up to my mind, and I decided to just discuss them. Now, the first question is, how much can I earn as a programmer? So here is the deal. You determine how much you can earn by the experience you're putting on the table. So there is an industry cap, industry benchmark, but there is no hard and fast rule to how much you can earn. In different industry, different caps are there. In different environments, different countries, different caps are there. So give yourself value. When you have value, then you can actually discuss your price or your worth with so much confidence. So I'll leave that to you to take care of. What industry is my programming knowledge applicable? Basically, you have 1,000,001 industry where you can apply your technical or programming knowledge, and this is an avenue for you to exploit. It's an avenue for you to look at the challenges they have in the different industries and how you can use technical solutions to solve those problems. That is when you can say your programming knowledge is useful in that industry or is applicable in that industry. So, for instance, if you have the on the fintech now, the fintech space, everybody is actually developing a solution for the fintech. How about you have the agricultural sector where you need to develop something for the agricultural sector as well? So you have to just think about a problem in an industry and think about how to use technology to solve that problem. That's when programming will come to mind as well. The third question is, how long does it take to learn programming? Averagely, if you're a starter, I would say between 3 months to 1 year is good enough for you to learn, because we have different learning abilities. So based on our learning abilities, we can actually say you can start from maybe 3 months. The first 3 months, you have an overview of what you want to do. Between the 3 months and 6 to 9 months, you should have a stronger grip of it. In those times, there are freelancers jobs, there are free tutorials, there are free resources you can play around with to make your programming skills well grounded, and that will help you in actually developing a stronger strength in that programming development aspect. So it can take you averagely between 3 to a year, depending on your personality, your learning curve, hands-on availability of hands-ons for you and all that. So, and willingness to actually take up challenges. So these are the things you can actually work on to make your learning curve faster. How do I know which programming language to learn? As I've said earlier, to learn a particular language is based on the solution you're trying to provide. If you think about a problem and you think of solution, then you can now come up with a particular language that will be easier to use, that will be faster in that situation. We have a lot of programming languages. They all have similar coding environment, coding ethics and standards, basically, but the only difference might be just speed, security. These are little things you have to look out for based on, is it the speed I need over the security, or the security over the speed, or I need the speed, I need security, I need ease of coding. You look into all those things and you read up reviews. I'll also drop some links where you can actually read up some more about programming, so you can have an idea of what to do and how to go about it. So I think basically these are the 4 questions I'll be talking about. But if you have more questions, as said, drop in the comment section below. Also, architecture. What do you mean by the architecture of programming? We have different programmers, we have different developers. So, for instance, an application developer, you can actually decide to choose a particular tree, a particular leg, a particular industry. So we have the web developers, we have the mobile developers, and we have the desktop developers. The mobile developers, they actually are in charge, or they design all the mobile applications we see, from the iPhone to the Android phones and all that. Name them. even some other devices that might not be Android based, maybe Windows C based and all that. Those are mobile developers, or they develop applications compatible with mobile devices. Then the web developer, yeah, we have the website developer, we have the web application developers. Those are people that design applications for the web, HTTP calls and all that. You have it on the web, posted somewhere, and you can reach it using your browsers. Those are web developers. Then we have the desktop developers. Those are the ones that make applications that sit locally on a system, so they are not readily accessible over the internet. So most of those applications are locally sitting. You have to come to the system, start the application, and know that they are locally based desktop applications, or these are what they do basically. So think about which of them you feel you have passion for, you have a flair for, and you can actually also learn a bit of it. We call something full stack developers. I think I'll talk about in the next slide. So we have the front end developer, we have the back end developer, and we have the full stack. No matter whether you want to be a web developer, mobile developer, or desktop developer, as a full stack developer, you should be able to do everything. But when you start with everything, it's always better to actually narrow it down to a core strength, so that your case won't be jack of all trade. So you have to narrow it down better to a particular strengths, either a front-end developer, a back-end developer, a UI UX person. You just have to narrow it down, or even a data analyst, narrow it down to know which of this is your strength. So as I've explained here, you have front-end developers. What are their strengths, requirements? If you're a front-end person, you'll be talking more or maybe HTML, JavaScript, CSS, React, and all that. All those are front-end tools that can be used to design or to use as a front-end developer. Then as a back-end developer, you're more or less talking more with to back-end. There are a lot of Node.js, Java. You use those ones as a back-end logic to write your back-end logic of an application. For instance, example, you have a website and it just shows news and all that, not interactive. That can be handled by a front-end person. That's a front-end developer's job. But when you now have an e-commerce site where you can log in, you can see a particular item, you can pick it, pick multiple items, save it to a cart, you can debit it, you can use your card to make payments and all that. That you need a back-end logic somewhere, or back-end developer somewhere, to help you put those logic in place, so that when that site becomes very interactive, information back and forth is actually residing somewhere. So you need a backend engineer as well, or developer, to handle that bit for you. Also, for instance, you have a school portal where you keep students' information, data, biodata, results, and all that. You will need a backend environment to keep or save those informations, because that site will be very, very interactive. It's a two-way communication. Request information, you get a feedback. So at that point, you have a backend developer and you have a front-end developer. And if you actually go for the third option, which is full stack, then you should be able to do both backend and front-end. And with that, we come to the end of this course. Thank you very much. See you in the next course. Bye.